per no liar-me fora. I com descarrego la nova? Ah, mira, vaig a fer l'error. Aviam, la meva hipoteca. Estic.
Well, hello. We will start in some minutes. Come someone else. Okay, so we will wait until 5 minutes, 3, 5, and we will start. Let's see if some spectators come, and we will begin all of this. So the spectators will wait a bit more to see it. 1 minute more, and we'll start. Okay, some seconds more, and we will start. 5 past 3. So okay, it's 5 past 3, so we will start. My name is Alejandro. I'm of the technical department of Industrial Sales Company, and today I will be showing you how to upload a code and sketch using Ethernet instead of using USB. This is really a really good option if you are very far from the PLC, so you don't have to move to the PLC in order to upload and sketch. So this way you can do everything remotely, and you don't have to move to the PLC. So okay, we will start from the first step. First step is to put a bootloader in the PLC, which allows this Ethernet communication. So the first thing we need to do to go and download the Ariadne Bootloader. Okay, if you see this Ariadne Bootloader, it's made for the Atmega 2560, which is the Arduino Mega, and it is of the version 5500, which is the one that uses our Ethernet chip. So basically, we need to copy all of this X file. That's copy it until here, and then we need to paste it in where our boards are saved, which is this. So I will open it from the beginning. So I got it pasted here in my documents, in my Arduino data, my packages, industrial chips packages, all these all inside here. Sorry, and inside the bootloaders, as we can see, there are 3 bootloaders. I've already made this paste of the new Arduino, so you will see these 2 files. So you need to change the original bootloader file, place it with another name. So for example, Arduino no Ariadne, and then you will have to paste the Ariadne bootloader with this name Arduino. It's really important because automatically it will burn this bootloader. So once we've done that, we need to burn our bootloader. So first step, sorry. The first step is to program one burner, which let me change to my camera. So if I take the camera, so as you can see here, I'm using an Arduino Mega board to develop this thing, to develop the burning of the bootloader, and it is connected to. It's not releasing. Okay, so the first step is to program this Arduino Mega in order to burn the bootloader. So how do we do that? So it's pretty easy. We need to go here, go to our templates, which are here, our examples, and we need to go to Arduino ISP. Easy. This is an Arduino file. It's for any board, so we'll find it pretty easy. And as you can see here, there are 2 resets, one here and one here, that are a digital output, which when the reset is placed to a high value, the Arduino resets itself, so it can burn the bootloader. So I'm using the pin tool in our blog. Also, this tutorial uses the pin tool, so I can do the same. So we need to use the pin tool for both resets, and we need to upload it. In my case, now I'm uploading to an Arduino Mega, so I need to select my board as an Arduino Mega. I need to select the port, which is already selected, and I just need to upload the code. The way I did it, let's compile. If it wants to. Okay, let's see, is it finishing? If you see that it takes a bit time, you can always click again, and it will be much faster. Oh, okay, it's already uploaded, although the PLC. And then also we will send it again. Okay, now it doesn't receive any error. So this is the first step to program our burning bootloader. And the second thing is to connect via SPI to our Arduino. So here, as you can see, I will also show the camera as well. And system would be like this. I will open all 3 photos, so let's see if it gets loaded. So here is the intercommunication. So the MISO is connected with the MISO, MOSI with MOSI, SDK with SDK. So all closes. I don't know why. Okay. And the pin 2, as you can see, is connected to the reset. And the grounds must be connected as well. So here would be the photos of this connection, and I will show you now the camera. So I can close this now. I will go to the camera. Okay. So as you can see, I will go closer. Let's see if it says correctly. More or less. Well, this pin is of the ground, so the grounds must be connected in order to have the same voltage reference. Pin 2 and the SPI pins, which are these ones. And I connect it to my SPI. It doesn't seems to look really well, but well, mostly we can see it. So the MISO, the MOSI, the SCK, the reset, and the GND are connected. I will end now the camera again. And we need to go back to our Arduino ID. So we're here now. So what do we have to do? Okay, it's really easy. We need to go to our board. Now we need to select the board will be so it's got an Arduino 58 plus. And it will talk using the port of the bootloader burner. So my Arduino, I will just burn the bootloader. So if I do this, we'll start to bootloader. Okay, so as here it says that the bootloading is already completed. So now inside our Arduino, we already have our Ariadne Bootloader installed. Okay, I take apart the Omega stuff. We do not need more. We will change it. Use the right one. Okay. Second thing. Let's see. Okay. The second thing is, if we want to send a sketch using Ethernet, we need to send a binary file. This is really important. Normally, using the USB, the file is an X file, an hexadecimal file. But in our case, as we're using Ethernet, we need to have a binary file. So how can we get a binary file from a sketch? Okay, it's not that complicated. It's really easy. But before telling us how to do it, I will show you the sketch I'm going to upload using Ethernet. Okay, in this sketch, as we can see, there are two libraries. This is from the Arduino Plus, and this is from the Arduino, the normal Arduino. So all our products now are Plus versions. The ones that we sell, we will use always this one. That is Ethernet 2. So it's configured for the Arduino Plus. And it's also this library, which is a watchdog. What's a watchdog? Watchdog would be like an alarm flag that is inside our Arduino. So when we call it, it actually proceeds a remote reset. So we do not need even the pin of reset for the bootloader stuff. Here is configured the MAC address of the Ethernet shield, and IP address, which is this one. We create a server on this port. And well, we start the serial, we print, so the remote reset is getting started. We start the Ethernet communication, we start the server. So until here, it's really simple. So in our loop, we will see if some client is looking for the server. So if we are talking to Arduino using the Ethernet, using this IP, so communicating using this IP and this port. Okay, and if it gets this is a Boolean variable, so if it gets to 1, it does all this stuff of the reset. And here you will put your test, your sketch. So the functionality, the exact functionality of the Arduino. So why this is important? Why I want to make a remote reset? So it is really simple. If I want to upload a sketch remotely, I only can upload if it's after the reset. So I have to make a remote reset in order to develop the remote upload. So okay, so this would be the code. Important things from this side, for this part, sorry, we'll have to go to our file, preferences, and here you can see that it shows output of the detailed output while compilation and while upload. Why is this important? Okay, I do not select it now. I will verify it. So if I verify this code, which is correct, it says okay, it's compiled, it's all good. But what happens if now I activate the preferences? You have the compilation and the upload. It does the same, but now it shows a lot more stuff. So you can see here. So as you can see, it's already compiled. But now the important thing, sorry, is this. So you are using a file which is compiled in this, in all this here, in the Arduino board, in a temporary file. Why is this important? Okay, this is important because when you verify a code, the Arduino IDE creates automatically in a temporary file the hexadecimal file of our sketch. So this is important because to get the binary file, we need previously the hexadecimal file. So now as it's getting compiled with the options in the preferences open, so we can actually see where is it saved. So we will go here. So users, webinar, APB data, local, temporary, Arduino code. So it's a 361,985. So if we go there, okay, here in my C in users, so users, webinar, here I have to go to APB data, to the local one, and I have to go to the temporary file, which is this one. So I've got it saved here, so it's a 36185. As you can see, I've already compiled different codes. So maybe one of these, most probably things one of these is the Arduino's ISP. So for the bootloading, sorry. So here if we go inside here, as you can see, we've got this file. This file is the X file of our init file, which is the sketch. So we need to copy this, and we will go to a known file, so to a known directory, sorry. So I can copy this and here is my directory. So you can see I already have it here. So this is my X file, so I will delete it. I will paste it again. Paste it, so okay, sorry. Problems of the direct. Here, users, go again, APB data, local, to temporary file, to this file, and I have to take this one. Okay, so I will copy it this way, and I will send it to here. So I will paste it here. So I will quit this one, and we will create our binary file. So how can we create a binary file from an text file? Well, Arduino IDE comes with some tools. One of them is the AVR Copy, which is the one that changes the X file to a binary file. And to develop this thing, we need to go using our terminal. So I will open it again. So way. It's called cmd command line. So we open it. We need to go to my directory which I want to go. So go to my desktop, here, my remote. So what you can see here, I got my Mino file, my ino.x file, and I've got this one, which is the command I'll be using in order to create my binary file. So before telling you what it actually does, this command, so I will just run it. As you can see, it's the binary file here. So what I've done with this command, so let's see. I've gone to a path, which is this one. So in my hard disk, my program files, Arduino, hardware, tools, AVR, bin. Here you can see it's the AVR Copy.x. This is the program which transforms the X file into a binary file. So my input will be an X file, which is called remote.ino.x, which is this one I got here. And my output will be a binary file, which is called the same way, but with the function of binary. So just using this, you actually create the remote reset, the binary file of the remote reset sketch. So now let's see, to summarize what we've done here now, until now, we've configured our Arduino in order to allow the loading via Ethernet, and we've configured Sketch to be a binary file in order to send this sketch to our Arduino. So what's the last thing we have to do? So it's really easy. It's to send this to our Arduino. So we need to have some things in consideration. We actually send it using our tftp. Right here, this is the tool we use to send a message. So my input will be the remote reset. I'm showing you the idea of this. Sorry, this has to have some space. We will put it to the host. So this will be the host. This will be the IP. I will put it the remote reset file. So this will be the idea that we will do in order to send the sketch into the Arduino. So how do we configure everything in order to send this? Okay. Uh, First of all, we need to activate the tftp. This is a tool that comes with Windows by default, but it is not active by default. So we need to active here. How I've come to this path? So I've come here and I put characteristics, Windows characteristics, which is this one, which is the same. And now I have to active telnet that I will talk after. This is for the remote reset, and this is the tftp that is for sending directly the sketch. So we need to active this. The most probably thing is that it tells you that you need to relog your PC in order to save all this configuration. I've already done it. Okay, and the second thing, this is a thing that I haven't told you yet. The Ariadne Bootloader provides inside this hexadecimal file provides an IP, which is this one. By default, is this one. I have to tell you that we are developing our bootloader, so maybe change in the future. But if you use the official one, that will be the Ariadne one. It is this IP. So we need to talk with an IP of this range. So it has to be of this range. So for example, this one would be an IP that is in the same range. So at the mask normally it's this one. if you don't understand about networks, it's really easy. This is a mask, so you cannot change these numbers, but you can actually change the last one. So a mask, an IP with this mask will be of this type, for example. So this has to be respected. No changes in here. And in the last numbers, can it be a value between 0 and 2.5. Okay, having said that, there's a command which is called ipconfig, which allows us to see which are our IPs. So you can see here IP configuration of Windows. So my Ethernet configuration, which is this one with this mask, as I told you. I've already configured my IP to have it in the same range. If you are also using Wi-Fi, care, because the most probably thing is that you can communicate with the Arduino. If you have the Wi-Fi connected, you need to do some pre-configuration. So the best thing to do is to connect directly to the Ethernet. But well, this is a different idea. I have to configure that in order to do the webinar and communicate using the Ethernet. So how can we get this IP, for example? Okay, so I got it already open here. This is my control panel in nets and internet. In my center of nets and shared sources, I've got my my active nets, which are the Wi-Fi, I've told you, and my Ethernet connection. And here is the point. I can show you. This is the control panel. So it's important. So I would go here, and I would go here. This is the path I followed. It's pretty easy. It's no problem to follow it. And well, to change the IP, it's really easy. I need to go here, and this is my Ethernet state. So we can see there's no internet connection. Sorry, but if we go to our details, sorry, we can see that our IP is this one. But what happens if it's another? So for example, this is a 2 or a 3 or a 100. So it's not in the same range. So we need to change it. So for changing it, we need to go to our properties. Here in properties, I'm not a root user. I need to place the password, but you probably can enter inside total entirety. And well, here as you can see, there's the TCP IPv4, and we can go to their properties. So the most probable thing is that you've got here this. So it already provides an automatically IP. So it's better to use this in order to select our IP. So it would be this one. This has to be, sorry, this has to be totally respected. And then, for example, I 120, we can put the one we want. So 25, for example. And normally the gateway by default is the 111. So the last one, which is not respected, we can change it. It's the 1. Okay, I will cancel this. So once we've already configured our IP before, we can go back again to ipconfig and see that we actually have our IP in the same range. Okay, so now we have the IP range correctly. We've got the tftp tool already configured, so enabled, we could say it in a way. And it is just as simple as go to tftp. I will talk to this IP address, which this IP address is the IP address of the bootloader, not of the application, not of this sketch. Although it is the same. Sorry, 1 second. And here I put the same so I don't get any confusion. What was the real IP of this? It's the same for both. But the thing is that this is the IP of the bootloader. So we need to be, the Arduino must be bootloading at the moment we insert the, sorry, at the moment we load the code using data. So now I won't do anything. So I will this and I will put my sketch, which go to our now. So I want to paste this one. It is really important to be in the proper directory. So if you use the, if you want to use this command, you need to go to the directory where it is saved. So as you can see, it's the same. And now I can put the sketch I want. So remote reset. Okay, before pressing enter, the first time we do it, it won't work. Let's give it some time. I'm telling you that it won't work. Oh, it worked. This is because I haven't done a sketch here, so it would work. But the thing is that we need to do the reset. So physically, if I go to my camera, first time we put the sketch uploaded here inside. I see it with the plastic. As you can see here, there's a reset hole, and here it's not really easy to see it, but here there's a button which is for reset. So as you can see, there are some LEDs that are lining up and down, and if I play the reset, it starts again. So now as I've got my sketch already put it here, if I try to do it again, it will tell you that there's an error connection. Why? Why there's an error connection if I'm using the proper IP? Well, as I told you, the proper IP is the one of the bootloader. So the Arduino must be bootloading. So if I now use manually, let's see if we can do. So as you can see here, there are two LEDs that are blinking, which means that the program, the sketch I've uploaded is already running. If I send it now, it says, hey, error connection. But if I prepare this and I press the reset button, now as you can see, it's not blinking. I can now upload the sketch and it will tell me, okay, everything is correct. So it should be. Well, as you can see, now as I'm uploading the same sketch, it's blinking the same. So if I don't press this reset, it won't, with a sketch inside, it won't upload the sketch. So why I tell you this? Okay, two main things. First one is for the remote reset. Basically, it's for the remote reset. Sorry. If we want to upload the code remotely, we want to not press this reset button manually. So how do we do that? So okay, first thing is to configure our sketch in order to get a remote reset. And the other thing is the tool that must be enabled in the Windows characteristics. Here. Okay, for doing the remote reset, we will use the Telnet client. In order to, it's like a client server configuration, TCP configuration. We need to, for doing a remote reset, we need to have the Telnet client and a previous configuration in our sketch. So what will we do now? Okay, so I will open another CMD. and I will go to Telnet. Okay, this tool is in order to communicate with the Arduino. I will now try to place the camera in the other corner so we can actually see what is working, and you will see that my fingers are not close to here. I've got only one hand now, but it will work. Open my IP. Open it again. Okay, before doing anything else, now this IP, the IP of the application. So it's the IP that we've put here. Although it's the same, it's not for the same interface. So one is for the Ethernet shield and one is for the application. One is of the bootloader and one is of the application. So I will close this now as we don't really need it more. I think I've closed the terminal. Okay. I will open it again fast. Okay. We go telnet. We go open. Go to our IP. And we open. Okay. First thing, it tells you it can open the connection to the host in the port open. So the most probable thing it does appear this to you. So we'll change this for the port to 2000. So if I go back to the remote reset, sorry, I shouldn't have closed this. So we can see here our server is listening using the port 2000. So I need to use this one in order to. Now tells it is connecting. So as you can see now it doesn't tell that it cannot be opened. And now it is really important to see that when I press some buttons, the PLC will stop blinking. So it means that we've developed a remote reset, which it is not pressing the button. As you can see, we can use it now. So now it's not blinking. I've done it manually. Okay, we will wait until it blinks again. So now it's blinking, and you can see in the command line, it tells you use any button to continue. So I will use one. The connection has been lost. I do not know why. So let's connect it again. Press a bad button. Sorry. You can actually use a word or the enter button. It will work fine. So now I've pressed the enter button, and as you can see, it's getting the remote reset. So this way you develop the remote reset. And if you can see now, it again starts the application. So I will try now to do everything on the same. Let's see here, and I want this one as well. So how do we actually do a remote reset? I will prepare this. I've got here, as you can see, the Arduino is blinking. And if now I press a button, I do not know what is appearing this way. Do a clear or a CLC. Oh, okay. I will close it because, well, it's Windows. Sometimes it happens, these things. So, okay, go back to Telnet. We will open, sorry, this IP, the application IP, using the port 2000. And we will prepare this. So in order to upload a sketch, first we will connect. Once we are connected, we will do the remote reset. As you can see, it's remoting, and now I use the other one. So now I'm uploading the sketch. So I've made first the reset, and then I've done the sketch. So as you can see, correct transference, this quantity of bytes, this quantity. So this way we would achieve our webinar, which is to upload our sketches using Ethernet from totally remotely, totally remote. Here now, I will put my chat. Okay, to spectators. Okay, I do not know if I can see my chat. I hope I will. See. Okay, well, if you have any questions or any comment, here is my chat. You can use the chat now as there's only one spectator. I do not know if you have a question. But if not, everything is set. So, as I'm seeing, anyone is telling anything, so the connection will be off. Okay, thank you very much. I hope you enjoy it. And, let's see you in the next one.